Hi, everyone.
Hello.
How's it going?
Hello. Good. How are you?
Good. We have t-tests today. Going to be exciting. All right. Let me set up Alex for you guys. All right. So everybody's doing good so far in the class. Everybody's hanging in there. If you have any concerns, let me know. We'll talk at the end of class, and I will address any issues you may have. I opened everything up, including the test for you for 1 week, so you had through this week. So that was good. And here we are today. We're doing t-tests. Are you ready to start? Ready to rumble on this? You can all hear me?
Let's go.
All
Yep.
right.
Yes.
All right. I'm going to take myself off camera for the sake of the technology aspect of this. And if you have questions, holler. So t-tests are when you have some of the data. Is everybody there?
Yeah.
Yes.
Okay, good. So the t-test is when you have some of the data. So you have a sample mean. So if you notice in this question, it says a coin-operated drink machine was designed to discharge a mean of 8 ounces of coffee per cup. In a test of the machine, the discharge amounts in 19 randomly chosen cups of coffee from the machine was recorded. The sample mean, the sample standard deviation are words you're going to hear all the time. So this is all about the sample. So we did the population with the z-scores. Now the t-tests, we're dealing with samples. So they give us 7.96 and 0.14 ounces respectively. If we assume that the discharge amounts are normally distributed, if there is enough evidence that the 0.10 level of significance, we can conclude that there is a change or a difference in the 8 ounces. They want a two-tailed test. So we're looking at is or is not greater than, okay? So let me show you some technology ways you can approach this. And let me show you some math ways you can approach this. So let me, you can see the question up here?
Yes.
Yes.
Yeah, you can read it? Okay, up there, okay. So I'm just gonna do this for a moment, just don't panic. I'm going to bring up my whiteboard. And in the whiteboard, we have a t-value. So we're looking at a sample t. Let me see what's going on here. Okay, so sample t-test is equivalent to the sample mean minus the t divided by the standard deviation s of x over the square root of n. That's equal to my t value. My t value requires the degrees of freedom. So you're going to take the population and minus 1. So remember, this is n minus 1. And you're going to find from that the t distribution value. So if you just take down that information for now, we could start. And as you have questions, we're gonna hit you with one question after another. And there's more than one type of t-test, so we're gonna pay attention and do this. So did you copy this down? By the way, this t is the equivalent of mu. So it's a sample mean minus the total mean, the population mean, over the standard deviation of the sample over the square root of n. And we're going to deal with degrees of freedom, which is n minus 1. Now, I want you to notice that in our case, I'm going to go back to the values that we had before, if you're ready. Okay. And that is, I'm going to go to Excel, which we like to do. So in Excel, I'm going to program the first one. I'm going to do this 4 times because there's 4 types of t-tests. And I want you to see where they come from. So I'm opening this up for you and put it to the side and putting this over here. All right. So the first thing I want to do is the sample mean, which they kind of introduced to you as 8 ounces. So actually, no, I take it back. The actual mean is 8 ounces. So that's the first thing they tell you. So this is, let's see what's going on here. This is the mean itself. I'm going to put an 8 here. And the sample standard deviation and the sample standard mean are right here. That's a 7.96. And if you look at the sample standard deviation, that is going to be the 0.14 ounces. Everybody see that in the question right there?
Yes.
If you look at the sample size, okay, size is Z, there is 19 of them, which means that when we talk about degrees of freedom, we want to do n minus 1, which is equal to the sample size minus 1. Our significance level. They're going to give us 3 significance levels. It's either going to be 0.95, 0.99, or 0.90. In this case, it gave us 0.90. And I want you to notice that I'm going to start with 90% confidence first. So let me do this. I'm going to do 90% confidence. I'm going to do 95% confidence. I'm going to do 99% confidence. If it's two-tailed, it'll be 0.95 for this one. So that would be 95%. This will be 97.5%. Actually, 0.975. And this will be 0.9995, 0.995. Okay, and this is going to be our critical value. So we're going to do this 3 times. Let's do, you know what, I did this next one. Let me not do it next. Let's do the significance level here. So in this case, you're going to go equals T dot And in this case, you notice that I'm asking you to do t dot inverse, where the probability is going to be 0.90, comma, and the degrees of freedom is always going to be 18. All right, and then you're going to do the same thing at 0.95, so it equals t dot inverse. Again, the probability is 0.95, and our degrees of freedom is 18. And the last one equals t inverse. I don't know what happened here. Oh, there you go. T dot inverse 0.99, comma, and again it's 18 because it's always n minus 1. And there's your degrees of freedom for one-tailed. These are all one-tailed right here. These three. Now two-tailed is going to be the 0.95. So I'm going to say this is 95%. This is 97.5%. And this is 99.5%. And we go here, we're going to say equals t inverse. Double click. We're going to say 0.95 here, comma, and degrees of freedom 18. And we're going to say equals t to inverse. Again, this is going to be 0.975, comma, degrees of freedom 18. And again, equals t to inverse. I don't mean to bore you with the repetitiveness, but this is also helping you learn, I hope. It's 0.995, comma, and degrees of freedom 18. So those would be your critical values. So this is all one-tailed right here, one-tailed. If you want to write one-tailed underneath it. And this is two-tailed. In this case, we're going to look at our two-tailed value, which is going to be 0.95, since it's 90% confidence. So this is two-tailed. All right. Now, the formula. This is going to be equivalent to equals the sample mean, which, like I said, is going to be the sample mean minus the mean itself. All of that is a value. And all of that is divided by the standard deviation divided by the square root of n. So that is the full sample size. If you want to put a parentheses around this part, it might actually not be a bad idea. And actually, I'll even do one over here because we're dividing by a denominator. And there's no difference there. There you go. And that gives us negative 1.24. What I want you to remember about this is we always use the absolute value of it. So it's positive 1.24 when you do the test as statistic. When we do the p-value, we're going to do the p dot dist. So in this case, let me go, this is the t-test or test statistic. Now they want the p-value. So the p-value, I want you to look at it like this. This is equal to t dot dist, 1.24 negative. Enter. Oh, I forgot the degrees of freedom. So you do the x, which is the number itself, the degrees of freedom, which was 18, and then it's a cumulative. So I think you select 2. It was this one. It was x degrees of freedom.
You have an extra closed parenthesis after the 11.
Say again?
There's a parenthesis closing after Bravo 11 where your cursor is. If you just hit delete. Oh, nope. At the end of the 11.
Mm-hmm.
Yeah, get rid of that. Hit delete. Yeah, there
Okay.
you go. Yeah.
And then cumulative. This is particularly interesting. When we do cumulative, you want to do true. And hit enter. So that's the p-value behind it. The p-value above it, you say equals 1 minus this number. And that's above. Now for two-tailed, we're going to say equals this value times 2, because it's two-tailed. And for the inverse array, you're going to say equals 1 minus that number. So one-tailed, two-tailed. All right, so let's play over here. The null hypothesis, according to this is going to tell us that go ahead. Anybody want to say anything?
8 ounces.
Mu equals 8.
What's that?
Mu equals 8.
So mu equals 8. I don't know why that happened. Okay, and what's the other one?
And is it mu does not equal 8?
Exactly, mu does not equal 8. Okay, and this is obviously the t-test. So we're going to go with t. Now, the value of the test statistic is negative 1.24. Let's go 1.25 if you want to go there. They want 3 or more decimals. I think 4 or 5. The p-value. They want, is there a difference or no difference?
It's twin-tailed if it's does not equal.
So what are you going to say? Are you going to go with 0.22 or 0.77?
Yeah, that I don't know.
Let's go with 0.2289. And lastly, if the p-value is greater than the alpha, which is 0.10, or p is less than alpha, we're going to reject the null hypothesis. So at the 0.10 level of significance, can we conclude that the true mean discharge differs from 8 ounces?
Yes.
I'm going to go with yes. Okay.
And
So-
the degree of freedom for Bravo.
Okay.
Is blank. Would that that's 18, right?
Mm-hmm. The degree of freedom is 18. But the point level of significance is 0.22. So we're going to comparing that to point D. The question is D correct? So let's check our answer.
No, I'm saying B is missing
Huh?
the degree of freedom.
Oh, what's the degree of freedom? 18, yes. Correct. So which part is incorrect?
It's E because
It's
the
E.
0.22 is greater than 0.10.
Exactly. So make a connection there. That is the key. P is less than alpha, we reject the null. If we fail to reject the null, then it's a no. All right, you want to take a quick cell phone picture of this? And let's do quite a few others, if you feel like you need it. All right, are you good?
Yep.
All right. Next question. Oh, let me send you this copy. Do you want the copy of Excel? Or assume you do?
Yes.
Yes,
Yeah.
please.
Yes, please.
Okay. Okay, so this is week 9. And this is t-test. Calculations. So I'm doing week 9 t-test. Let me close it out. I'm gonna send it to you right now. All right, everybody, here she go. Here she goes. Should be loaded. Let me know when you got it. Did you receive it yet?
Yes, we got it. I got it.
Got it.
Got it.
Awesome. Go ahead and open it up and let's play with this. Okay. I'm opening it up. I'm gonna leave the other part open for you to see. Bear with me for a second. I'm trying to make this bigger. Okay. So here you are. I'm going to give you this question a little bit bigger so you can see more of it. All right. Take a look here. If you need me to make it a little bigger. So the number is for the sample size
17.
17, right? And he claims that their mean, so if the series entering students find that their mean IQ is 120 with a standard deviation of 14, the previous score, the records of indicate that the mean IQ score for entering students from previous years is 111. So I think that this is the mean itself is 111. And I think that the sample mean is 120. And I think the sample standard deviation is the 14. Any issues with that? No? Okay, so this should be mu is equal to 120, I'm sorry, 111. And what about the sample or the alternative? What is the alternative going to be?
Mu equal to 120.
No, that's the null. What's the alternative?
Greater. Mu is greater than 111.
The mean is greater than 111. Okay. So obviously this is a t-test with degrees of freedom, which is equal to 16. What's the value of the test statistic?
Two 2.6505.
Okay, so 2.651.
2.651.
Yeah. What's the critical value? It's 0.05, one-tailed. So the issue here is you're going to go with a critical value. So we're going to say equals T. Dot inverse. We're going to go with 0.95, comma, and this time 16. And that gives us 1.74588. So 1.746. And if p-value is less than the alpha, p is less than alpha, we're going to reject the null. What do you think?
Yes.
Okay. All right. Are you feeling confident?
Can we do one more?
Well, we're going to do many more. Yes, we're going to do one more. Here you go. Sample size. $15, right? Finds the mean IQ of 122 with a standard deviation of 15. So sample mean 122, this is 15. It says the college records indicate that the mean IQ score for previous students is 112. So what are we gonna say? Mu is equal to 112, or mu,
Is greater than 112.
yes. Good. What type of test statistic is this? T-test. How many degrees of freedom? 14. So what is the value of the test statistics?
2.582.
2.582. The critical value.
negative 1.761.
Positive. Right? So it's greater than.
Okay.
So P less than alpha, reject a null. If OV is greater than CV, we reject a null. So either one will work. So let me say this here. You can say P is less than alpha. In which case you reject a null. Or if the observed value is greater than the critical value, then you're also going to reject a null. What would you conclude?
What's OV?
You accept
Observed value, the test statistic. Critical value is the critical value that you see in the.
All right, so then we would be rejecting this one.
We would what do reject what?
The null.
We reject a null. Okay, so then what would this be? Yes or no? You say yes, right? To that.
I don't know. That's what always gets me backwards.
So here's the thing. Here's the thing. If I say I'm gonna reject the null, I'm gonna put a big X over HO. I forget about this top part. I'm looking at the bottom part as being true. Read the sentence again. We conclude, using a 0.05 level of significance, that the mean IQ score of this year's class is greater than. That's what it says. So we'll say yes.
Cool.
Okay, let's do one more and then we're going to do a different type. Okay?
Yeah.
Is everybody cool with that?
Yep.
Or am I going to be, if I, no?
Yes.
Yes, do it again? Do another
Yes.
one?
One more, and then I guess we can go to another one.
No, we'll do what we need. All right. You go ahead and work it out. You have this Excel sheet. So when you tell me the alternative and the null hypothesis, if you're ready.
Mu equals 113, and then mu is greater than 113.
Yes. So mu is greater than 113. Again, test,
P.
t-test, degrees of freedom.
13.
16.
It's 13.
Sample size is 14.
Oh, the sample size.
So the degrees of freedom would be 13. N minus 1, remember that. All right. What is the test statistic?
1.07?
1.06.
9, I guess. Oh, 69.
Yeah. So
Oh,
have a
because it's on 3
I have a
decimals.
question.
Sorry.
Why isn't the sample size 17?
That's what I thought. I thought the
random
standard.
sample of 17. It
Yeah,
is
it's
17.
It is 17.
So this is 16. All right. The test statistic?
1.178.
1.178. Excellent. Oh my goodness. Bear with me, teacher. Teacher having technical difficulties, okay? 178. There you go. Okay, the p-value. Above
1.746.
can it ever be 1 point?
7, 4, 4.
It should be 0.128, negative 1 point or positive 1.28.
Now, how did you get that?
It's 1 minus the lower value. This is the area, the 0.871995 that you see here. You see my cursor
Yes.
moving? So this is the area above it. So this is the area below, this is the area above. This is always where you have greater than values.
So what's the formula I have for that one is B13 times 2.
No, that would be only in a case where you're looking at two-tailed on this side. This would be the answer.
Oh, okay.
This is one-tailed. Okay, here, let me do this. Do this as well.
Okay.
One-tailed. Two-tailed. Where this becomes times 2.
Okay.
So yeah, it'll be whatever this is equal to whatever that is. And it's two-tailed, so it will be times 2, which is not going to ever happen at this break because then it'll be 1.
Right.
It's 1 above. And the same thing here. Yeah, this would not work for a 0.87. So P less than alpha. Alpha is 0.05. P is less than alpha, we're going to reject the null. You are greater than alpha, we're going to fail to reject the null.
I hate that it's worded.
Yes. I think it's yes.
You think it's yes?
Yeah. Yeah. Guess.
Okay, stop and look at why. Stop and look at why. We conclude using the 0.05 level of significance that the mean IQ score of this year's class is greater than. They're saying that this is greater than. So they're saying that we are going to fail to reject a null.
They're saying that the 0.05 is greater than
No.
the
So
mean.
if 0.05, which is the level of significance, that's the alpha value. Our p-value we said was 1.128. Is 0.128 less than 0.05? Yes or no?
No.
No. So no is the answer. So is 0.128 less than 0.05?
No.
Absolutely not. So we're going to fail to reject a null. If I fail to reject a null, I'm saying that no, it stayed the same. So no, I'm not gonna say it's greater than. Does that make sense?
Yep.
All right. Do you want another or?
Yes, can we do just one more?
Yeah, yeah.
Yeah, I definitely need to practice too.
No
That,
worries,
that,
no worries, no worries. All right, there you go.
okay.
Take a moment. Let me know when you're ready.
I think I'm ready.
Okay, so we begin with,
Mu equals 120.
all right. And what is the alternative hypothesis?
Actual value is higher, so it's greater than
Okay, so you say mu is gonna be greater than 120. Good,
120.
all right. So what is the test statistic?
T,
T. And what are the degrees of freedom?
16,
Good. What is the value of the test statistic?
2.151.
Ooh. And what is a critical value? One-tailed test
0.024.
is a 10%, 0.10. Remember, one-tailed 0.10.
Oh, I see it up here.
So I'm gonna go here. It is already on B5, so it's 1.337.
Okay.
Okay. Moment of truth. If OV is bigger than the CV, we're gonna reject the null.
Right.
So which is it?
Yes.
I'm gonna say
Good job. How do you feel?
A little better, but still feel like I'm guessing.
Let's do one more. Let's do one more. And then after this, we'll do the other one, okay? Is that okay with everybody else?
Yep.
Yep.
All right, here you go. Let me know when you're ready.
Mu is equal to 30 centimeters.
Mu is equal to 30. And what's the alternative?
Mu is not equal to 30.
Mu is not equal to 30. Okay, good. Obviously, it's a t-test. How many degrees of freedom?
13.
13. The value of the test statistics.
1.069.
Yep. And what's the p-value?
1.695.
Okay, let's go with that. I'll
How
tell you
many?
why it's
That'd be 5, or that'd be 96. Sorry,
okay.
not rounded.
P less than alpha. Reject the null. Differs, doesn't differ.
So no.
No. Okay. I want to talk to you about D for a minute. Let's go ahead and hit this. Do you notice D is incorrect?
So is it not twin-tailed?
It is twin-tailed. It's two-tailed for
The
sure.
inverse?
Huh?
No, that doesn't make sense.
You're 1.771.
What is that?
I said, was it 1.771?
Okay, so you're going to change this to 1.771. All right, let's check that. No. So this is the idea. In this case, you have to change. Okay, so it's two-tailed. So yes, we're going to do that. But in this case, you get this, and this is equal to 2 times this value, 0.3045. Maybe that's it. So in
So,
other words, it has to fit in between 0 and 1. So if I do this times 2, it gives you 0.3. If I do the 0.84 times 2, I get 1.69. Not doable. Because it's two-tailed, you try both. Okay, so just for the record, all I did was take that times 2. So you're gonna do that in either case. So you want to make sure it works.
so
Alright.
why doesn't that make, or how do we know to use the bottom set?
Because
for,
this one goes over 1.
no, I meant if it was a single tail, how would we know?
Oh, if
to
it's
use
one tail, you're gonna use this for less than, which is anything beyond below the z-score, and this is anything above the z-score. But because it's two-tailed or twin-tailed, as
so
you call it, this is times 2.
Got it.
Okay, so let me go ahead and do the other example. So this is, I think, can I dare say that I think they're all going to be the same? I thought you guys have more than one t-test. Okay, let's do this one. This should be good. So in this case, mu is equal to, what's our number?
$45.
And the opposite would be mu is not equal to 45. So what is a test statistic? T-test. What's the degrees of freedom?
9.
The value of the test statistic.
$2.875.
Yep. The critical values. It's two-tailed. They're looking at 95% significance, so it's got to be the 2.262. So here's my suggestion. Negative 2.262. And positive 2.262. Now,
I think it's,
question of truth.
is it the 262 or is it the 1.833? It's
These
not,
are one-tailed. These are two-tailed. So this right here, this entire column, this is all two-tailed.
okay, so if it says,
This is all two-tailed. And 95% significance, you got to split 0.05 in half and
okay,
give, yeah, so it becomes 0.975.
gotcha. Okay, two-tailed, you split it in half.
0.05 added to 0.95, 0.05 and a half. So, can it be concluded that the population mean height or treated plants is different?
Plus, critical.
I'll say it again, OV greater than CV. OV greater than CV. OV is 2.875, that is greater than the CV of 2.62.
So we're failing to reject. So that's yes.
This is not a fail to reject. This is OV greater than CV. Remember, CV is the critical value. OV greater than CV, we're going to reject an all. If I reject an all, that means I'm going to accept the alternative hypothesis, which is not equal to. What do you think? Yes or no?
No.
No.
We're failing to reject, so it's yes.
Correct. OV greater than CV, reject an all. All right, let's try another one of these. So we're gonna say that mu is equal to 700. And here, we're gonna say that mu is less than 700. It does a t-test. Degrees of freedom is 17. And the value of the test statistic,
Negative 2.333.
and the critical value, it's one-tailed. These are all one-tailed on the other side of the yellow.
1.739.
Yeah, 1.7396.
Oh,
I'm
7.
wondering if you're gonna round this. Let me see. Let's round it. Make this a little bigger for a minute. 740. I'm rounding these to 3 decimals, so I don't have to think about it. And there you go here. All right, same thing here. I'm gonna round these. All right. So we're gonna say in this case the critical value is 1.740. Now, here we go with this part. Read C carefully. P less than alpha, we're going to reject a null. P is 0.016, isn't it? Isn't that less than 0.05?
Yes.
So is it a yes or is it a no?
So it's a no.
Less than, so we reject, so no.
I'm going to go with no? Think about it.
If you're rejecting, then it's a yes.
You're rejecting the null. You're saying it's a yes?
I'm just basing it
I
off
am
the
saying
variables.
yes.
Feel
Okay,
like-
so I'm rejecting that mu is equal to 700. I believe that mu is less than 700. We're correct on E, but D, they say, so what's the issue with this one? D is incorrect. Find a critical value. The critical value is 0.05. Let me double check that. Yeah, 0.05 B5. Make it more decimals. Why would this be wrong? Okay, I'm sorry. I'm having a issue with this. Three nine six 7.73 1.7396. Okay. Let me change it to 0.7396. Maybe it'll like it better. Let's see. No. Find the critical value.
Is it negative?
Oh, could it be negative? Yes, it could. That's it. Why is it negative?
I just did the formula again. I just did the T inverse of 0.05 and then the degrees of freedom, and it came out to the same answer but negative.
Yeah, that's exactly why. The other thing that's telling is this is negative. They're both negative. They're both going to match. All right. One more of these? Yes?
Yes.
Hang on a second. I have to get out of here. All right. Here we go. All right. Let's see how many of you get this. Okay, so what's the mean? Mu? What is a mu?
42.
42. What is the alternative? Mu
Less than
is
42.
not equal to 42. All right. So that once again, the t-test and degrees of freedom, that should be 12.
12.
Okay. The test statistic?
Negative
Sorry. Negative 1
1.803.
point. Yeah.
803. Okay, the p-value? Let's go with that. 0.0482.
It's two tailed, so wouldn't it be the 0.9?
9.6.
Oh, wow. 0.965. 66? Shall we say 66? Great job. What's the conclusion? Alpha is 0.05, is 0.0966 less than 0.05, yes or no?
Yes.
So 0.0966 is less than 0.09, 0.05?
No.
No, it's not. So we're going to fail to reject a null.
And that's yes.
That's a no.
I can't get this straight.
Okay. I look, it's okay. Here's what I want you to think about right now from E to A. Go to E to A mentally. A is they're not different. B or H1 is there's a difference. In the hypothesis here, they're saying, can you conclude that the height of treated plants is different from 42? So I'm telling you to fail to reject this. If I fail to reject this, I'm going to hang on to this. And therefore, they're not different from 42.
Okay. Wow, that makes a lot more. That makes it click a little bit better.
It's a lot to take in because sometimes you get so tongue-tied and you get tired of looking at the same thing. You guys are staring at this for an hour and a half. I'm trying to, help you understand it. Let's do another one. If you can hang in there. Are you ready? And those of you not talking to me, tell me what's going on because I can't read minds if I can't see you.
I'm good.
Okay.
I'm following along. I'm just updating the Excel and stuff.
Okay. Well, here, try this one. Let's see how you do. Okay, so the null.
It should be mu is equal to 65 and mu is less than 65.
And yes to that. Good. This is obviously a T. Obviously, degrees of freedom is 9.
9.
Awesome.
And then the value of your t-test is negative 2.52.
Yeah, this is kind of tricky. It's 2.5.
2.530 if you
Yeah, let's
round,
go with that. Let's go with 30.
but
But it should be negative.
Negative. Very good. Now, the p-value. 0.016.
Mm-hmm.
Okay, if p is less than alpha, we're going to reject the null. Alpha is 0.05. This is 0.1016.
So no.
So we're going to say yes, that we're going to reject it because the 0.016 is less than 0.05.
So you're going to say yes to reject?
Yes.
Are you getting it? Most of you? Or all of you?
I'm getting it.
Yeah, I'm good.
Yeah.
Anybody not getting it?
I'm not like 1,000% confident, but I'm doing all right.
What are you not confident about?
I guess it's just like repetition that I need.
Okay. So that is what I'm going to cover for this part. I've shown you each type of this type of math. Do you want to do one of those the section on your computer and share with the group?
No, we can just do whatever you had planned. That's fine. I'll just review as as I do the Alex homework during the week.
Okay. Does anybody want to do their homework on the computer here? I'll work it with you. No?
I will. I mean, why not?
Come on down.
Okay, let's
Let me
see.
shut myself off. Go ahead and you got to share screen, multiple screen. Okay, so you can share your screen with us.
Okay, 1 second. I'm logging into Alex.
Are these sessions helping you? Are you understanding the material you got? I mean, it's not just a process, it's also understanding that you're comparing the mean. And based on that and the population size, the sample size, you're able to determine if there's a significant difference between them or not. That's the gist of what you're learning right now in the sample size. Okay. So if you take out your Excel sheets, you can do these with us, everybody. So I want you to follow the question along. If you can make the suggestions or what have you, that would be awesome. Okay, so what's the sample size? Anybody?
Okay, hold on. If I'm
Just the number of participants.
17.
17.
Says it right there. They're looking at the sample mean to be 700. The sample standard deviation is 691. The sample standard deviation is 17. We're looking at a p-test of 0.05 alpha.
okay. Hold on, I think I missed something. We have the mean as what?
700.
700, not the sample mean.
The sample mean is 691.
Oh, 691. The mean is 700.
The standard
sample
deviation,
mean
17.
17, that's where it was. Okay.
Mm-hmm. So what is the first null hypothesis?
What we're using like this, so less than equal to. So
Equal to mu
mu
equal to,
oh wait, hold on.
yep, 700.
To 700.
Uh-huh. And now the next one says mu is less than.
Less than, yes.
Good.
Okay.
T-test,
Yep.
degrees of freedom.
Degree of freedom, I have 16.
Okay. Test statistic.
A statistic, I have, you said it can't be negative though, right?
Yes, it can.
Oh, again. Okay.
Negative.
Negative 2.18.
2? No, wait, 3?
3.
3.
3, yeah, 3 decimals. So find the p-value. This is one-tailed. So is it the 0.044?
I believe so.
No,
Give
I'm
me
sorry.
a second.
That's-
I accidentally closed out on a part of my sheet and I'm trying to, okay, there it goes. So what is it again?
0.022.
Yes.
Okay, now hold on, let me make sure. Using the 0 point level so that we can conduct at the mean monthly rent for apartments on the east side is less than 700.
0.022. Yeah, 0.022. Is
Yeah.
one-tailed. So if P is less than alpha, 0.022 is less than what is it, 0.05?
0.022.
What's the alpha?
You're saying less than 0.05. So yes.
Yep. So that is definitely, okay, good.
Okay. It's like you have to read that last question slow, very slow. That's what made me too. I'm like, and then I had to put
Definitely.
it over here in the spreadsheet to physically look at it.
Yep.
So, okay.
All right, what's the next one?
Who turns 91 this year? So this is gonna be 120. So that's gonna be greater than with the 17 as a sample. So this is 122. Standard deviation. That's standard deviation. So this is gonna be 20. Okay, so that's what I got. So I had mu is equal to 120.
Yep.
Mu is greater than 120. We have the t-test.
Okay.
The
Degrees of freedom.
Oh, the degree of freedom is 16. The statistics is 0.412.
Okay.
The critical value 0.05. This is it 1.337?
Is it 90% confidence, 95% confidence, 99% confidence?
95%.
So 1.74.
0.74, sorry.
Yeah. 1.745. 1.745.
Shop
746. 746.
Okay.
Hmm.
Okay, now this is the one I have to read slowly. Now, yes, because it is greater than. So hold on. 1.746 is greater than 0.05. Am I reading? Oh, wait, no. No, yes, that's right. I'm going with yes. Am I reading it right?
So the test statistic is the OV.
Oh, it's okay. So
Is the OV is greater than the CV.
the CV
Is
is
the critical value 1.746.
1.746. And the overall,
So you're gonna fail to reject a null.
yes.
You failed to reject a null. What are you saying?
Okay, hold on. OV is what is OV again?
OV is the test statistics. So
Okay.
that is greater, is that greater than the CV, which is 1.746?
Okay, you're saying, is it greater than 1 point? Okay, so no, it's not. So it's
You're
gonna
gonna,
be
you're gonna fail to reject a null.
correct.
So fail to reject a null says they're equal to, so there's no difference. They're not greater than. So yeah, you're good.
I think I wrote it wrong though, the way that I was looking at it. Open operator drink. Mean of 9. 22 random cups. Sample size is 22. And mean is going to be 8.88. With a standard deviation of 0.23. I feel like that's wrong.
So you should have a sample mean of 8.88, a regular mean of 9, a sample standard deviation of 0.23. A sample size of 21, a degree of freedom of 20, a degree of sample size of 22, a degree of freedom of 21.
Yes, okay, so I did fill it in correctly. Okay, so it's gonna be
Mu is
Mm.
equal to.
mu is equal to 9.
Mm-hmm. And the other one, obviously, not equal to.
Not equal to.
Degrees of freedom 21.
Yep, 21. The tests, I have negative 2.447.
Mm-hmm. Now this is a two-tailed. So your two-tailed should be 0.023.
Right here, yes, 2.023, okay. 0.023.
And now your alpha is what size?
The alpha is 0.05
Mm-hmm.
and my
Your
P-
p-value is 0.023. If 0.023 is less than 0.05, you're going to reject the null.
if it's less than, it's greater than.
P-value, which is 0.023, is that less than?
Oh, okay, I'm sorry, I put 0.23, so it's 0.23, sorry.
Okay, is that less than 0.05?
Yes,
So you're going to fail to, I'm sorry, in that case, you're going to reject the null.
check the null, yes,
I'm rejecting the null, says I'm accepting the alternative.
right. So yes, it's true.
Hmm.
Okay. Less than 750, a random sample, size of 18, with a mean of 743, standard deviation of 16. Sitting 750. Okay. So this is going to be
So mu is equal to
to 7,
50.
is it 750 or 743?
750. $743 is the sample size and your sample mean.
750 is the
Mean,
mean.
the mu.
Oh, so 743 is the sample mean?
Correct.
So that's gonna be 750. So this is gonna be less than
Mm-hmm.
the mu,
Mm-hmm.
let's see, 750
750.
T. And degree of freedom, we have
That's 18. What's 18 minus 1?
17.
Hmm.
This is gonna be negative 1.856.
Mm-hmm.
We are doing a one-tailed critical value, so I'm gonna go with
Is this a 0.05, 0.01? What is it?
the 95, so.
95.
Oh, wait, no, is it? No, it's gonna be 90, right? It's 1.0, right?
So 1.333.
So it's gonna be 2.567?
Oh no. Go back up. 0.10. 90%
Oh, yes, no, I was right. So it's the 1.333.
Yes, that's correct.
Okay. Okay, so using this significant, we can conclude that the mean monthly requirement is less than 750. So here we're doing this way. So sorry, I have to write this out. So that's gonna be negative 1.856 is less than the critical value, which is 1.33. Oh, so it actually tells you if you put it in there yourself. So it's true. Did you see how I did that in the cell? And it came up and said true.
Oh, I don't know about that, but go
I
ahead.
think that's what I don't understand. All I did was put the numbers there and then it just said true.
All right, go ahead and select it.
Let's see if it's right. So it's not. Oh, D is wrong. So we did critical value of 10%. So what did I do wrong?
Negative. Negative. Put a negative in front of that.
This one, the critical value?
Put a negative.
Now, can you explain that to me? Because I don't see the negative here.
Because the OV is negative, so this, therefore the CV is also negative.
Okay.
Okay, you got 2 more. Let me at least give the class a chance to say you can go if you need to.
No problem.
If you don't want to and you want to stay, that's fine. I'm just going to finish the last 2 with you, but if you're good, I'll see you next week, all right? You guys have been great. All right, go ahead. Number 5.
Okay. Random sample. So sample size would be 14. Their mean IQ would be 119. Standard deviation of 10. And Should be like 13. So here we will have equals to. The mu is equal to 119.
Mm-hmm. Well, hang on. No. Look at that carefully.
Let me see to find their mean IQs on 18, but they standard deviation. Students from the previous years 1-3. Oh, okay. I mean, I keep reading it as if it's back. I'm reading it backwards.
What's the sample size?
Sample size, I have 14.
Okay. All right.
So this is going to be 113. And this is
Greater than.
I see it greater than.
Mhm.
That's what I was looking for. It's greater than. T-score. The test
Degrees of
size
freedom.
2, 4, 5. The degree of freedom is 13.
Mhm.
The p-value, so this is a one test. So a one tail, sorry. So I have
So
it
you're
in,
looking at above, so 0.0221. Because they want greater than, so 0.021.
I have a similar question that like she's working on,
Mm-hmm.
and I got the p-value wrong, and I'm not sure exactly what I did wrong on it. But my numbers are different. I guess that's normal. All of our numbers
But-
being different.
Yeah, that's true. But what is your
Well, I
Let me-
got the p-value wrong on mine.
okay? But the p-value, the one-tailed is where the 0.978. Have you seen my screen? No, you don't see my screen. You wouldn't see my screen.
Well,
No, I'm seeing
I can
hers.
stop sharing. Do you want me to stop sharing real quick?
Can you see my screen now?
I guess so. Yeah, or you're on there as
Yeah, can you see it now?
yeah.
Okay. So you see here on this side, right here where I'm going to highlight. This is the area of below, this is the area above.
All right, hold on a second. I'm not seeing where you're highlighting. I don't know if let me just make my screen bigger. Hold on. Okay.
So what is your t-test? What does your sample mean?
My sample mean was 119.
Okay. The mean itself?
Was 115.
Okay.
The standard deviation was 13,
Okay.
and the sample size was 10.
Okay. So in your case, you should have selected if it's greater than 0.117986.
Yeah, the problem I got was when I put the answer in, it was telling me that I got E right, I got D wrong, which I don't understand because I took it right from the p-value from my Excel.
So the p-value would be the bottom one, is what I'm saying, because this is above.
Oh, dummy. Okay, sorry, my bad. Yeah, you have to have those aha moments at times.
All right.
Thank you.
No worries. All right, let me stop the bench share. You got that one right? I see. Stop share.
Oh, yeah, I did. I'm sorry.
I saw that. All right, good
All
job.
right. Okay, so this is okay. So this is going to be equals mu equals 6.
Okay, and then mu is not equal to 6. It differs. It's a
Yes.
two-tailed. Okay,
The T with degree of freedom being 18. The test is negative 2.42.
what's your sample mean?
My sample mean I have 5.85,
Okay, and your standard deviation,
0.27.
okay? So you got a negative 2.42.
Correct. I got a negative 2.2. Oh, hold on, what was I looking at? I don't know. I was looking
No,
at.
no, no, you're right, you're
Yeah, yeah,
2.4.
2. Okay, yeah, because
Yeah.
rounded it up to the 2.
All right, and what is your, what is your critical value?
The critical value of a two-tail would be
0.05, 0.975? So 2.101, negative 2.101 and positive 2.101.
yes, right here with the.
Yep,
Oh, so you have. Oh, well, yeah, it makes sense. You always have to
negative and
do it
positive, yeah.
first, right? Yeah. Okay, so we can conclude that the true mean discharge differs from.
OV greater than CV. Now, regardless of the negatives, even if they had no negatives, if the OV, which is 2.422, is greater than 2.101, regardless of the negatives,
Okay, so it'll be 2.422. True means differs. And the critical value is 2.1. Yes, because
so it is bigger, right?
yes, it is bigger. 2.422 is bigger than the 2.1.
So we're gonna reject the null,
Correct.
so therefore, yes, it differs.
Yes, it differs. So I guess that means that true statement that keeps popping up is right.
All right,
Okay.
good, one student down for homework.
I know.
Yeah, I'm just about to finish. Are we allowed to
You
go
wanna,
now?
do you wanna share yours? Gail,
Oh, no, I'm pretty much finished. I was just have to submit the last question.
do you wanna share it?
Not really.
No, okay,
I'm
great.
sorry. It's 20 to 8
offering.
and it's 20 to 8 and I'm a diabetic, so I need to eat. That's why I was
Alright,
just
have a good
checking to
night.
see if we could go. All right,
Have a
thank
good
you.
night. Alright, anybody else have questions or anything? If you're good, you're free to go. I'll see you this coming week, and I'll send you the information.
I do have a question.
Yeah.
I sent you an email about, I guess, the last lab. I'm not sure if you received my email.
No, what was the question?
You sent out an email about the grades for the last lab, and I guess I was missing the whisper.
The box whisper.
Box whisper. I was wondering if I was able to go back and change it. or
Submit
add-
it, yeah.
Okay, and then resubmit it.
That's all you gotta do.
Okay,
I'm waiting.
I will go right ahead and
It's
do
not
it.
just you, it's not just you, it's like a bunch of you. I'm like,
Oh.
I'm waiting.
I know, because I see that the email went out to everyone, so I was just making sure that we were still able to do it.
I I have never said no to rework.
Okay. I will
Okay.
go ahead and
Does
add
Does that
it.
include everything?
That what?
Does that include everything like that we've done so far?
Yeah,
Are we able to like redo it, or like if we missed it, we can turn it in?
hopefully, yes.
Okay.
All right.
Yep, I'm good.
All right. I'll see you guys. Have a
Bye.
good one.
I had a question too.
Oh, yeah, go ahead.
In regards to the test, I wanted to see if you would be able to open that back up for me. I sent you an email last night. I was in progress with it and had some had some daughter duties I had to take care of and it lapsed on me.
All right. I'll open up.
Appreciate it. And when will I have the ability to
If I open it, I'm gonna open up a couple of days and then you have until the 2 day. How many days do you need?
Maybe till Thursday. I work
Okay.
the next 2 nights,
All
so
right, no problem.
you're awesome. Thank you so
No
much,
worries.
Dr. B.
All right, have a good one.
All right, take care.
Bye.